So now, blackbody radiation. It's just a theoretical idea saying that a body that is black, that will also absorb all of the energy if any energy comes upon it. Any radiation that comes into the black body will absorb all of it. But we use this concept to describe the surface or the state of that object. So a black body is a surface that completely absorbs all incident radiation. Now a unit of a black body value, or a certain parameter that we use to describe the black body surface, is this unit, megawatts per micrometer per steradian. So when it says per micrometer, it's for a certain wavelength or a certain color. Per steradian is for every solid angle, for a unit solid angle. Now we look at this graph. This black body it absorbs, but then it also emits radiation. We can think of it as being as something that a surface that emits the radiation, because here we see the black body value with the unit megawatt per meter square per steradian and so on, and the wavelength. This graph shows that B, lambda, the black body value for a particular wavelength, and then this is lambda micrometer over the wavelength. This is the intensity of the black body, and this is just a different wavelength, and the different wavelength is for different colors. You notice that for a wavelength less than 0.5, the black body radiation value is small. But then as you go up higher, then in wavelength, then the black body radiation goes up to a peak value and then start to decrease. And then we see the same trend for these different curves. Now the key features here is this peak here in the middle. And another thing is that if the black body has a certain temperature value, the amount of radiation that escapes it, the black body, but just the amount of temperature that is on the black body would be high at a certain wavelength. So if the black body is at 5000 Kelvin, then the black body value is about 11 or so. But as it has higher black body value, it corresponds to a higher temperature range. So if the black body is at 7000 Kelvin, it's about 3700 degrees Celsius. 6,700 degrees Celsius. The black body value is higher. Actually, from here, we can denote a temperature of a surface just by knowing the wavelength. This is what it means in terms of application. It means that if we know the wavelength and we know the black body value, we can guess the temperature. And that's how scientists have found out the temperature of the sun, just by knowing the wavelength and the amount of intensity that reaches the Earth. You get information from radiation that comes to us, and that's how they study space. So this is one of the ways of how they measure a temperature of a surface or a temperature of anything. And that's how they guess the temperatures of different planets, of different objects in space too. They relate radiation to temperature. Now, how do we calculate this curve if we want to know how it behaves with micrometer? You notice that it's follow more or less standard curves, right? So we can describe this using an equation, and that is the equation. The black body for a certain color, which is a function of temperature. So this black body value equals to C1 times the wavelength divided by pi, which is another constant, exponent C2, another constant, lambda is the wavelength, temperature. This is the key thing. If you change the temperature here, the peaks change to n minus 1. And if you have, let's say, 7000 K, you plug into this equation, and this lambda here, you change from 0 to 2, and you calculate this, you should be able to replicate the curve.